What a fascinating, massive, impressive structure that was revealed by James Webb Telescope. And this structure showcases four massive layers, and these four layers are essentially dust that was produced by some impressive form of radiation that is from a particular group of stars. And this group of stars, we call them the APEP. And so we're going to look into details concerning this particular process that was quite hidden for a couple of years, and then recently with James Webb Telescope's technology, how this reveal has changed and modified our understanding about cosmic behavior in out of space. Now, before these four shells were finally revealed by James Webb Telescope, we had just one shell that was really noticed before we had James Webb discover these other three shells. And this shell here was produced by two particular massive stars, according to this article. And these two massive stars were around 20 times the size of our sun, and currently they are slowly crushing down, and as they're crushing down they are releasing this amount of dust. And according to analysts, it says that one of these massive sun actually spins so fast that it fills out dust, or it spills out dust in elegant spirals, as you can see in the images. And this here is really fascinating as well, because this particular information shows that it was released for around 700 years by this type of stars known as the Wolf-Rayet stars. Now, James Webb Telescope results combined previous results from the European Southern Observatory and the very large telescope that is in Chile. And so narrowing down these particular results allowed us to reveal that this has three massive stars. And yes, we talked about two at first, but this third one here is a supergiant star that is pretty much close to around the range of 40 to around 50 times the mass of our own sun. And this star here is so massive that once it is crashing down, it releases a lot of dust particles that spirals as well. And this here shows that these three are really gravitationally bound together. Therefore, the future of this particular observation is that there is going to be some point where these massive stars may eventually become black holes, and this close together and gravitationally bound is going to be fascinating to see how this year will change our understanding about how supernovas are formed in such a close gravitationally bound space, and this amount of dust particles that are being generated. According to this article as well, it states that the type of particles that are being released here, dust particles, are mainly carbon-rich particles that are spewed out in space. And the speeds that these particles are spewing out ranges from around 2,000 to 3,000 kilometers per second, which is really massive. Other properties of this particular dust is that it is known to be really dense, and so this kind of dense carbon particles, as they are spewing out into outer space, they tend to do what? They tend to reveal a kind of a fainter color as they are more diffused. But it's quite impressive how James Webb Telescope is able to detect such faint colors that is produced from these carbon high energy particles. And so thanks of course to the mid-infrared, they were able to reveal the other shells that are spiraling from just the inner core to outer space of this particular image. Now, this article kind of states how rare this particular event occurs, and in terms of context, it says that these Wolf-Rayet stars are around 1,000 of them in our specific Milky Way. But out of these stars that are 8,000, there is only one that we're able to find to be showcasing this APEP behavior. And so it's quite fascinating to see how this is really portrayed right now and what the future is like when it comes to this spinning behavior that is occurring that produces this form of energy particles out of space. And this is accompanied with a particular simulator that is produced by James Webb Telescope, and over a couple of data collected shows the layers in 3D, which is pretty cool to see, and how it rotates. You can actually see the spiral take on each of the layers, and it doesn't really make you to see what the stars or how the stars are, but based on James Webb Telescope, it says that there are three massive stars. One, of course, of the three is a supergiant sun. So pretty fascinating stuff right here. Let me know your thought about this particular result that is produced by James Webb Telescope, and what the future is going to look like in terms of our understanding of massive star behaviors, such as this rare one that we have right here. Hope to see you on the next one. Stay smart as always and believe yourselves.